the test of independence, we'll be using the chi-square test of independence. So in a volunteer group of adults age 21 or older, adults volunteer between 1 and 9 hours per week to spend time with a disabled senior citizen. Some of the volunteers, sorry, that should just say some of the volunteers are students at a community college, some are students at the four-year institution, and others are not students. The following contingency table summarizes the classification of volunteers and the number of hours per week the volunteer works. And then we can ask this question: is the number of hours volunteered independent of the type of volunteer? So that's the question we're asking. That is the clue that we should be using the test of independence. Below is our data summarized on the contingency table. So if we state the null and alternative hypothesis, first you identify your variables. Variable 1 is the amount of hours volunteered. Another variable over here is the type of volunteer. So here's the types of volunteers, and here is the other variable, the number of hours per week worked, and the independence test, the null hypothesis, says the amount of hours volunteered is independent of the type of volunteer. And then the null hypothesis will take the opposing view and say the amount of hours volunteered and the type of volunteer are dependent. All right, so now let's begin the test. Now, if you go back and observe, we do have to have a significance level. It's not stated. And when it's not stated, we just assume that alpha is equal to the 5%. Okay. This will be using the chi-square distribution. It is always a right-tailed test. So if we come down here, we are going to be looking for, oops, let's put that in red, a 5% area here. We need to calculate our critical value. So we'll be calculating from the table our chi-squared of 0.05. To do that, we need to know the degrees of freedom. The degrees of freedom are the number of columns minus 1 times the number of rows minus 1. So going back to the contingency table, you can come over here. Oops, it's up top. Up here, we have 3 rows and 3 columns. So the degrees of freedom are 3 minus 1 times 3 minus 1, or 2 times 2, which is 4. Then we can go to the chi-squared table and find our critical value, and our critical value is 9.488. Now we need to calculate the test statistic and label this test statistic on the diagram. So using our calculator, we will get that chi-squared is equal to 12.99. We will do this by into matrix A. We're putting in the table, that the contingency table from above. And then remember, you go to stats, tests, and you want to pick the chi-squared. Okay. The observed go in A, the expected go in B. We'll leave that blank, and then you hit calculate. And when you do so, we will see that chi-squared is equal to 12.99. Now, clearly this is inside of the rejection region, so even without knowing the probability of the p-value, we see that we are going to reject h sub 0. But on that same screen where we calculated chi-squared, where our calculator calculated it, we saw that the p-value is 0.0113. So either way we do this, we are going to reject h sub 0, either because our p-value 0.0113 is less than alpha, which was 5%, or because our test statistic, which is 12.99, is greater than the critical value of 9.488. The important thing here is that it is inside the rejection region. And after that, then we can summarize our results, and we can say at the 5% significance level, there is there is sufficient evidence to support the claim that the amount of hours worked and the type of volunteer is dependent.